Good afternoon, everyone. My name is Brittany Stowe, and on behalf of our team at Carasoft, I'd like to welcome you to our HashiCorp webinar, Cloud Success for Higher Ed Institutions with HashiCorp Vault. Carasoft is the trusted government IT solutions provider. As a top-performing NJSBA, educational technology products and related services, and Internet 2 contract holder, Carasoft has served as HashiCorp's master government distributor and aggregator for the public sector. Working as strategic partners and through a robust ecosystem of value-added channel partners and system integrators, Carasoft delivers HashiCorp solutions to federal, state, and local government agencies, as well as the education community, supporting the public sector's mission to prepare for the digital future and modernize approaches to IT through the application of open source solutions. Our contact information will be at the end of the presentation, so please do not hesitate to contact us for any of your needs. And at this time, I'll now pass it to Hunter Folks from our sales team.
Good afternoon, everyone. My name's Hunter Folks, and I'm a HashiCorp sales specialist on our open source team here at Carasoft. I'd like to welcome you to today's HashiCorp webinar. If you have any questions after the event, please do not hesitate to reach out directly to me via the information displayed on your screen or to our Carasoft team, whose information will be provided at the end of the presentation. Today, HashiCorp will discuss how Vault can update your institution's cloud operating model by accelerating transitions to the cloud, modernizing and optimizing IT infrastructure, and doubling efforts to protect systems from security threats. At this time, I'd like to introduce our speakers for today's Cloud Success for Higher Ed Institutions with HashiCorp Vault webinar. Tim Olson. Tim Olson's an accomplished technology professional bringing over 30 years of extensive and comprehensive experience advocating, designing, and implementing innovative technology solutions. He's currently a staff solutions engineer for HashiCorp, responsible for enabling multi-cloud and hybrid cloud solutions for public sector clients. Mehdi Ramdan. Mehdi is an IT Associate Director at the University of Florida, leading the Identity and Access Management and Infrastructure Reliability Services teams. He's been with UF for 8 years in various roles, including workspace virtualization and cloud engineering. Mehdi enjoys traveling and cheering for the Seminoles as an alumnus while working for the Gators. Grant Hudgens. Grant is a systems administrator and Programmer 5 in the Identity and Access Management team at the University of Florida. They have been with UF since 2019, working in various roles, including configuration management and automation. Currently, they are focused on the Shibboleth SSO infrastructure, multi-factor authentication, and secrets management. Tara Genus. Tara Genus joined Internet 2 3 years ago after a career in international telecom and government IT contracting in the Northern Virginia area. Her current roles enable her to facilitate collaboration between cloud service providers and the higher education community for mutual benefit. Passionate about international education, she holds an undergraduate degree from Georgetown University and a graduate degree from the London School of Economics. Tim, the floor is yours.
All right. Thank you, Hunter. Very much appreciate that. And thank you, everybody, for joining our call today. Really appreciate your time. As Hunter was describing, we're going to touch a little bit today on some of the different approaches and models that HashiCorp offers, specifically in the area of Vault and how to address things like security challenges as we move into this ever-changing world of dynamic infrastructure. So as Hunter said, I'm Tim Olson. I'm a solutions engineer here at HashiCorp. And we're going to address and kind of kick off the chat today with everybody's familiar with how things are shifting in the IT landscape. So we're all familiar with the traditional approach of a static environment, the enterprise data center, the castle and moat approach here for protecting everything with a nice secure perimeter, and everything is known, access is known, networks are known, all those kind of things. And we're seeing this whole adoption, as you all know, we're all facing this over the last many years, of that whole dynamic aspect of the whole data center or really enterprise cloud type environments. This is a much more frequently changed environment, right? It's unpredictable infrastructures. The perimeter is not defined. The infrastructure could literally stand up and run anywhere within the cloud boundary. So you don't own the infrastructure, you don't own the networks, you don't own any of these environments. So the whole aspect of dynamicism is very beneficial to rapidly changing workloads and demands, but it also presents a different set of problems and choices for how I secure that environment. And when this whole new infrastructure approach has introduced a new set of principles, so to speak, in the IT side, right? So you're all familiar with this change. We're all already familiar with how the traditional data center operates. Again, we have dedicated environments, we have a high trust area. We know how everything operates within that environment. As we shift over here and adopt a more hybrid or multi-cloud approach, this is where we have resources that can run pretty much anywhere at any time on demand across any operational platform for the most part. And this really affects these four key stakeholders in the IT environment, right? So we see the shift in infrastructure, where we're moving to a more automated approach using APIs and dynamicism around infrastructure as code. We see the challenges for security about moving, again, from that high trust IP-centric environment to a much more identity-driven environment, the ability to protect this entire infrastructure across the whole operational platform. This is what we focus on today. Other things we see as a challenge are, how do I now connect this environment? We see a more service-based or service-driven environment where I have services could be running anywhere in this operational environment. And I want one service to find and detect another one that connects securely, another challenge. And of course, how do I run, schedule, and control and orchestrate applications across this environment? So as we move into this dynamic environment and those key stakeholders and those key approaches change, we're seeing this whole growth of secret sprawl, right? So now we have secrets, or basically any piece of information that can be sensitive, that can be used to potentially open a vulnerability or compromise your environment. Those are all secrets. As we move more and more into this whole hybrid multi-cloud approach, secrets sprawl is exploding. Now, here's just a couple of reports here from the Git Guardian. But again, a secret could be anything like a username, password, an API key, database credentials, certs, all these things. We see these secrets everywhere across the environment because you need them to be able to access and operate your whatever your applications or your workloads might be. But it does present a unique problem in this whole hybrid landscape. And of course, this opens up potentials for higher ed as well. Right? As you can see here, this is another report on where you see vulnerabilities, and a lot of them are around compromised credentials or secrets across this environment. Again, this is where risks come in, vulnerabilities come in, because it's such a broad ability to run applications and workloads. And this is what we focus on today, is how do we secure that environment? How do we introduce this secure layer of this new model to say, I want to protect secrets, I want to protect sensitive data across this whole operational environment, regardless of where I have workloads running. And this is what HashiCorp Vault was designed specifically to address and solve. And you'll hear in a few minutes here how the University of Florida has taken this approach and has taken HashiCorp Vault and used that to address some of these key challenges. And very cool stuff. You'll hear from them here in a few minutes. But fundamentally, HashiCorp Vault helps address and solve that security layer to provide a secrets management platform or solution across any environment. So fundamentally here, we won't go through a ton of detail. Happy to jump into this further discussions if anyone would like to go into more detail. But Vault acts as that central secure secrets management environment across any operational environment. So I have fundamentally how it works is I have a client or basically a Vault user that says, I need a secret to do something. So Vault will go to an already used authentication environment. So you may be using, a JOC token or a Kubernetes or, LDAP or something like that. Vault will take this request, authenticate that to make sure you are who you say you are. It'll assign the associated policies with that request, that this is what you're allowed to do. And then it will provide the secret back to the request store, assuming you're allowed to do that, which now allows that request store, could be a database or user or whatever, to access whatever environment it needs to go. So this gives Vault that fundamental secure plane that offers authentication, authorization to be able to access whatever back-end environment that you need to get to in a secure fashion. So as we see this whole, what HashiCorp calls the cloud operating model, right? This ability to drive this dynamic environment across those four key stakeholders, we see this security automation model being deployed in many environments. And you'll actually see this as the University of Florida team tells you about some of the things they've been doing today, some of the aspects they have going with Vault. They actually will talk about how they've taken this whole automation model or this maturity model, and you see them actually implementing and standing this up. So you'll see Vault in action, you'll see a lot of the cool things they're doing, and you'll see some of the plans they have for going in the future. Really, really cool stuff. Also want to mention, as we talked about this challenge and we talk about how do I really provide this fundamental secrets management or security layer across any operational environment? Again, it could be on-prem, in the cloud, a combination of all of them. The other aspect we face is the whole challenge around zero trust, or fundamentally identity-driven workloads and control. So this is another area where HashiCorp helps really solve a zero trust security model. Vault plays a key role in there. You can see Vault here providing an identity-driven environment. Everything within Vault is identity-based. So now I can have machine-level authorization, application-level authorization. So I don't necessarily rely on a specific IP. I'm going to have it all identity-based. So this gives you a lot more flexibility, and it helps address a key aspect of a zero trust workflow or a zero trust environment. We also have multiple other solutions here with Console Foundry. Again, we won't get into any details today, but if anybody's looking for more information on that, please let us know. And Vault, of course, also works to support the human authentication side, right? So if we're using Okta or Ping or some of these other environments, Vault is that core secrets management environment to help enable that single sign-on type approach across a zero trust model. So what we're fundamentally talking about here, to sum up kind of what is Vault, Vault really lays down that foundational cloud security layer, that security management and control layer across any operational environment. So this enables you to have an identity-based workflow. Everything within Vault is identity-based, so Vault acts as an identity broker. Again, great for zero trust workflow. It provides that secrets management layer where Vault can now centrally manage, store, and protect whatever your sensitive data is across any operational environment, and additional capabilities around data protection and data enablement, right? How do I support an encrypted environment or encryption as a service? And Vault is already set up to do that because everything within Vault is, of course, encrypted, right? And you'll hear some of these capabilities here as we move forward, and let the University of Florida team tell you about some of the exciting things they're doing and standing up Vault. So thank you for your time here. I appreciate that again for just having a basic understanding of Vault. And with that, I'd like to turn it over to Mehdi to take us through some of the exciting things that the University of Florida is doing, some of the technology they deployed, and some of the plans they have for the future. Mehdi, it's over to you, sir.
Thank you, Tim, and good morning or good afternoon, wherever you are. We're very excited to join this presentation. Grant and I, and we'll take you through kind of how we provide Vault as a service in UFIT, a history of how we came about, using Vault, and the whole progression since 2017, what we call the Big Bang Big Bang time, where Vault really kind of started growing with Shibboleth, some of the use cases we currently use, and what are next steps. So Vault as a service is provided by the Identity and Access Management team, which is located in a unit called Infrastructure and Communication Technology in UFIT. We're basically the unit that provides all the infrastructure pieces, whether private hosting on our VMware clusters or public cloud deployments in Azure, AWS, or GCP. I manage two teams, and one of them is the Identity and Access Management team, which has 7 systems administrators. Grant is one of them. And we make Vault as a service available to all UFIT units right now. And that is about 7 or 8 units. So that includes research computing, academic technology, and so on and so forth. The IAM team manages the infrastructure, all the VMs that provide Vault, all the backend dependencies for it, and also all the configuration for Vault. We also review and approve all the policies and the roles that teams submit. Right now, we have most of our deployment in the Vault open source, and we're migrating to Vault Enterprise. So we're still using that concept of just one namespace, and Grant will touch on that later. And finally, the IAM team is the one responsible for any incidents or issues. We have on-call rotation. So if anyone cannot access Vault, or if we see an increase in, for example, auth logs where we have some Vault agents that are pinging our Vault in a abnormal way, generating a lot of traffic, we're responsible for the incident response as well as the investigation for that. The history of Vault in UFIT kind of started with us adopting infrastructure as code, and specifically Terraform. In 2017, we kind of started with one Windows server with Vault on it, and we're at the tail end of deploying VMs using infrastructure as code, and we're doing Power CLI and then trying to move to Terraform. It wasn't really that developed until in 2018, where the University of Florida IT decided that we need to review our Shibboleth deployment, which is our IDP for all SSO. And we want to rebuild it in a much more resilient way using containerized approach. And that one, the secrets management came into play. And especially when you talk about automation, end-to-end automation, it forces that consistency and repetition. How do we handle secrets there? So after in 2018, that project was completed, we used Vault open source for that. In 2019, we started seeing a lot of cloud deployment requests, specifically in Azure and AWS and GCP. So we followed the cloud adoption framework, and we had the cloud enablement team created. And similar to the approach we took on premises, Terraform was chosen as the declarative language to use for deploying resources instead of learning CloudFormation and Azure RM and Power CLI internally. And all of that work kind of pushed us naturally into a GitOps framework where we use GitLab as our version control, source control system, and use GitLab CI also for pushing those changes to whatever cloud we're deploying to, private or public. We completed all of our Azure GCP configuration with Vault there in 2020, and then we realized that now we're big enough that we need features that are not available in open source, namely the namespaces feature, where we remove ourselves as the policeman in the teams send in us like role requests and policy requests, etc., and give a much more self-service experience to all of our teams. Next, I will hand it over to Grant. They will take us specifically and dive in depth into how we use Vault and specifically the Big Bang moment of Shibboleth and the use of Vault.
Hello. So yeah, like many of you, we use Shibboleth as our primary SSO identity provider. And as Mehdi mentioned before, we had an initiative to containerize our Shibboleth deployment. And like that mainly spun out of reliability concerns, as well as a desire to create flexibility on where we ended up deploying our IDP clusters, whether that be local infrastructure or one of the many cloud providers. We wanted the ability to build these container images, perform automated tests on them, deploy them to a variety of environments, and store them in a registry where we could quickly and easily roll back if any of the clusters had a problem. Obviously, we didn't want to bake secrets and environment-specific configs into these container images. So the solution that we came up with was Vault. with console as a storage backend and key value store, and then using console template for building shibboleth config files. We built two main CI/CD pipelines in Jenkins to build, test, and then using Ansible for orchestration, deploy to our various environment shibboleth IDP clusters. I can walk you through those two pipelines. Let's start with the shibboleth build stage. So first, we grab the base TAPS shibboleth images from the Uncommon registry. We then inject template files, the console template binary, the console template config file, and any of our custom shibboleth configuration files that do not contain any secrets or are not environment specific. Next, Jenkins will use its own Vault app role that we defined to pull console Vault credentials that have console/Vault policies scoped specifically to the shibboleth test environment. With those specific credentials stored in the Jenkins workspace, it will then spin up the containers which are configured to run console template on startup before any other shibboleth services are started. Once the container is up and running, we run a series of automated tests. These cover everything we could think of from, guaranteeing file permissions are what are expected to actually authenticating through shibboleth with a test account. When all the tests have completed and passed, Jenkins will then publish the modified container to our internal GitLab registry, and then alert us saying that everything was good. So moving on to the deploy stage. Our shibboleth IDP clusters are built on a series of Linux VMs. So one at a time, we will put each of these VMs in the cluster in downtime inside our monitoring system. And then just like in the build pipeline, Jenkins will use its Vault app role to pull console/Vault credentials that are specific to whatever shibboleth environment we are deploying to. But instead of keeping them in the Jenkins workspace, we'll actually be pushing them to the Linux VMs through Ansible. Jenkins will then leverage Ansible again to pull specific versions of the shibboleth container images. For example, with production, we would be pulling the latest version that has been verified in our beta environment. Jenkins will then spin up the newly pulled containers, which are, as I mentioned before, configured to run console template on startup. Then we will run through what is essentially the same set of automated tests that we used in the build pipeline. If all of these tests pass, then we remove the monitoring downtime from the node that we've been working on, then repeat all of these steps through iterating through all the nodes in the cluster. Once all the nodes are complete, we will run through authentication related tests again, but against the load balancer's virtual IP. Yeah, we wanted to give you a brief summary of our current use cases, which we have listed on the left, before diving deeper into some of them, as well as show all the ways that Vault can be used, which you can see on the right in the diagram that we borrowed from the HashiCorp documentation. Obviously, one of the most common, but possibly least interesting use cases is the Vault key value store. We essentially built a kind of folder structure inside the KV that's split between teams and services. This allows the teams to, easily create policies that are scoped to, whether it be a team or a services space. And then the rest of these we'll dive into in the following slides. So yeah, starting with policy management workflow, as Mehdi touched on here, we manage all of our Vault configuration policies through a GitLab repository that has Terraform definitions in it. And we leverage the Vault Terraform provider. And then when someone needs to make changes or define new policy inside of Vault, they will check out this repository, then they will create a new Git branch. They'll make all their necessary changes inside that branch. Then they push that branch back to GitLab and generate a merge request to merge it back into the main branch. At this point, a GitLab CI/CD pipeline will trigger, where things like Terraform syntax checking will verify everything looks good. It'll do a Terraform plan to make sure that there's no obvious Terraform gotchas that we'll run into. And as long as those check out green, we'll actually see that inside the merge request. Then once the merge request is created and everything looks good, the IAM team is notified, and the first available person on the team will review the changes inside the merge request. The main thing we're looking for is that no one is essentially growing policy scope larger than they really need. And also, like ensuring that things that do not need like write capabilities don't have write capabilities and so forth. If needed, we'll pull in approvers from other teams if there is something that does kind of grow out of a team's normal scope space. But yeah, in general, we usually do most of the review ourselves. Once approved, the IAM team member will merge the branch back into the main branch. This will kick off another GitLab CI/CD pipeline that goes through the same testing, but finishes off with a Terraform deploy command run. And that's what actually ends up applying the configuration/policy changes to our Vault instance. On the far right, on the far right, we do have a screenshot of the general structure of that Terraform repository. Yeah, CI/CD pipelines are one of our biggest uses for Vault. We leverage the GitLab JWT auth engine in Vault to apply Vault policy for specific GitLab projects at like their CI/CD job runtime. The pipelines then have the ability to pull whatever secrets are needed for the job, and it's also like lets it censor any values that are in the logs. Previously, we handled CI/CD secrets using the GitLab CI/CD variable settings for the project. And this was problematic because anyone who had admin rights to a project could then go and view these secrets at any time they want, and there was no audit trail showing when they were accessed and by whom. SSL certificate lifecycle is another big use case for us. Another team actually ended up building out a GitLab project where, using YAML files, any other team could define and manage their needed SSL certificates, automating the generation and renewal of said certificates. Anyone could create a new merge request inside this repo, defining new certificates inside the YAML, including a variety of settings, including things like alternative names. Then once approved and merged, a CI/CD pipeline would use the Let's Encrypt API to generate or renew certificates, and it would also handle making any kind of like DNS records that are necessary for Let's Encrypt to verify DNS ownership. Then it would take these new certificates, including any chains, private keys, CSRs, whatever, and push them into Vault, where each team then has their own paths and policies. Then the teams could use whatever method works best for them to deploy the certificates to whatever service, whether that be through a Vault agent install, console template like I covered with Shibboleth, or just any other CI/CD pipelines that leverage something like Ansible for orchestration. SSH authentication is something that we more recently started doing with new Linux host deployments. We started leveraging a cloud init configuration during the Terraform deploy stages that will configure the host to include any necessary user counts and configure it to trust Vault signed client certificates for SSH. We built a custom tool called VSSH, which is really just a wrapper for OpenSSH, where a user will just need to authenticate to Vault using the Vault CLI tool, then run VSSH, whatever user at whatever host, and VSSH will handle the communication with Vault to grab a signed certificate and then pass that along to OpenSSH for client authentication to the remote host. This means that we no longer have admins that are regularly SSHing into servers as root. And admins also no longer need to memorize the root passwords because, no longer need to memorize the root passwords, and there is a central auditable trail of when someone logged in, and also by having MFA authentication at the Vault layer, this now basically requires MFA authentication to SSH into Linux hosts. Service accounts. So Active Directory is a big one where we already are using the Vault AD secrets engine for automating password rotation for many AD service accounts. And we're currently working on policies and procedures that will essentially require all new service accounts to be managed by Vault. And we'll be able to then take those policies to start updating the old existing accounts as well. For cloud deployments, where we have a lot of people across campus that are leveraging cloud services for a variety of different things, we didn't want people using their normal or even like their privileged access accounts for directly deploying resources to these various cloud offerings. The primary concern being generating large bills without realizing what they were doing. So we handle the resource provisioning through GitLab CI/CD pipelines that leverage Vault to generate temporary service principals with specific roles in whichever environment, and that's what's used to deploy the predefined resources. Then once the deployment's complete, the temporary service principal is removed. So what's next for us? Big focus is on migrating away from the Vault open source implementation we have over to Vault Enterprise. We're validating a lot of the policy and procedure plans that we have, specifically with namespaces. We want to make sure that they will work in like an actual real world use. We definitely want each team to have their own namespace and associated Terraform repository, but we are still testing out exactly how we want to handle the service spaces. We also want to migrate away from the AD secrets engine to the LDAP secrets engine. The primary motivator here is really just the AD engine is being deprecated. So then we are also working with other teams to expand our usage of the various database secrets engines. Our big use cases being MSSQL and MySQL, but are actively working on integrations with others such as like Snowflake and PostgreSQL. We want to expand the use of account libraries so that teams and services can manage/check out a set of credentials instead of dealing with individual accounts for everything. We want to migrate away from our current certificate lifecycle GitLab project that was mostly spun up because of like time concerns, and we were able to get it working with Let's Encrypt pretty quickly. But with Let's Encrypt, we had to deal with the whole DNS verification, and what we want to migrate to is in-common SSL signed certificates through their Acme service, and actually have Vault directly handling all of that. This will simplify, it'll simplify a lot of things, and yeah, then we won't have to deal with the DNS ownership. And then we have several university applications that go through regular load testing. That load testing uses service accounts. Currently, those accounts have their credentials rotated through manual triggered procedures. We would like to have Vault actually handle the whole password rotation automatically, and then have whatever load testing suite be able to directly check out the necessary credentials directly from Vault. And with that, I'm actually going to hand it over to Tara.
I see we have two questions, though. I don't know,
Tara.
Brittany, if we want to have those addressed first.
We're going to address questions at the end of the presentation.
Oh, okay, great. I'll start my video then and get present. Hello, everybody. I wanted to just kind of follow up on, what Grant and Mehdi have done is exactly, and Karasoff is a facilitator and HashiCorp is a partner, is really what we're all about in the Internet to Net Plus program. So for those of you from the university community who might not be familiar with Internet 2, just a real quick briefing as to why we exist. We're really here for the U.S. higher education institutions and community to grow at scale initially it was using networks. We have a large research network and that began about 27 years ago. But then in the last 10 to 12 years, really working with the community in adopting the cloud and cloud services and doing collaboration across all the different cloud service providers. And as it's matured with services like HashiCorp's Terraform and Vault, always looking at what the community needs to better manage their cloud adoption and how they grow securely and collaborate both within their own universities or institutions, but also across. And so some of the ways that we work with, in my role, working with industry partners like HashiCorp and Karasoft, is trying to identify those cloud services that the community is interested in, needs support with, wants to collaborate, working with. And we've done that through a number of programs. The Cloud Scorecard is one that HashiCorp participates with us in the regarding Vault Enterprise and Terraform Enterprise. And in terms of helping build awareness throughout the research and education community, but also it demonstrates their readiness to support higher education, the unique requirements we have, whether it's in compliance, security, privacy, contracting. So the Cloud Scorecard really is there to help the community members identify those vendors like HashiCorp that are kind of aligned with their needs from a procurement standpoint, technology, and that they're ready to really address that and work with the community. And so we help facilitate that not only through the Cloud Scorecard program, but also through Net Plus, which we have currently. The vendors shown here are in the Net Plus program. That's a much more active engagement with the vendor and the community doing a service evaluation. So the service evaluation that goes into all the things that we ask in our Cloud Scorecard questionnaire that the vendor completes, then in the Net Plus program gets evaluated by the community. So institutions like the University of Florida that would work with their colleagues to evaluate a service. And so one of our goals today is to find out, we hear of interest throughout the internet too and higher ed community of working with HashiCorp on a service evaluation. And so we would love to hear from institutions that want to do things to work together, this peer-to-peer sharing, like University of Florida has been so gracious to do today, happens throughout the service evaluation, but also through the Net Plus program and the program manager. So these are some of the areas where we really work through the Net Plus service evaluation, the outcome, what we get from it, terms and pricing that are attractive to the higher ed community, security, accessibility, all the things that matter when they're deploying a service. And for both parties, both the vendors as well as the higher ed institutions, it just allows there to be a quicker engagement, to get services deployed, and just feeling that confidence and working together, sharing ways that they are addressing challenges and what the outcomes are. So, the Net Plus program is unique in the sense that this rigorous service evaluation process that then negotiate terms of the contract that then gets administered by companies like Carahsoft, and basically the idea is to benefit the growing community in terms of consumption and having just more awareness of what's possible, the art of the possible. So just a couple resources here in terms of contact information regarding the Net Plus program, the Cloud Scorecard, but also a link there to the internet to Cloud Scorecard, where you can look up the information about HashiCorp Vault and Enterprise as aligned with higher ed requirements. So I thank both HashiCorp and Carahsoft for participating in our programs and helping the community identify and adopt services. And that's it for me.
All right, thank you, Tara. Appreciate the update there, and thank you for going over all those programs you have. So I'd like to go ahead and just touch base here. We talked about Vault today, a little bit of what Vault provides and some of the capabilities there. And you heard from the University of Florida team who are actually standing up and deploying many of these capabilities and many of the things coming forward for enterprise and some of the things they have planned there. So probably one of the things we probably want to do now is jump in and answer some of these questions. So first question from Jesse. There's a question here that says, what kind of adoption of Vault and CI/CD have you had from the Windows teams? I don't know if Grant or Mehdi, you want to jump on that one?
Yeah, sure. I can take that question. So we had a great adoption of Vault and CI/CD. The key elements that we've implemented there is first project templates in GitLab. So the teams, if they want to deploy a VM using Terraform, and all the Windows teams right now, I think except one, they all are very, very familiar and comfortable with using Terraform in their deployment. So they use that project template to deploy it. The second thing is CI/CD templates in GitLab. And in that project template, it uses those CI/CD templates as well. They're already been set for them. So the only thing that the team has to do, in addition to know what their VM name is and the subnet they want to use, etc., they just have to provide a Vault role that they want to use for that pipeline to be able to authenticate against Vault and pull the appropriate secrets, and a project access token to do some commits back, which actually when the Terraform finishes, we get the output and we store it as a markdown file in that project as kind of a documentation in addition to the inventory file. The other part of it, so in addition to the templates on the GitLab side, we have documentation, and we've done one-on-one sessions with teams to show them how Vault works, how they can submit, create roles, create policies, how they can define them, declare them, use the Vault project that Grant and I talked about earlier. And we did hand-holding for a few times, and then after that, they were pretty comfortable moving forward with it. And we just approve their merge requests or ask some questions if there is something that is out of scope there.
Okay, and it looks like probably the next question might be a good one for either Mehdi or Grant as well. Another one from Jesse is, do you use Vault for sharing secrets between humans as a replacement for 1Password or other?
Yes and no. So we do have a lot of individual users that are directly going into Vault through like the UI or even the CLI, but we are avoiding trying to present it to anyone as an equivalent of like your normally expected password managers. Vault was never really intended to be used like that. Like, for example, they don't have a browser plugin that can autofill things and stuff like that. So it's primarily for infrastructure.
Yeah, and I can add to that. So right now, the users who have access to Vault, which is all UFIT folks, we have the space for services. So those are the kind of the passwords that are that need to be accessed by more than one team. But I've seen, to a lesser extent, people using the wrap and wrap functionality inside Vault. If the two parties have access to Vault, they can just have that whatever secret they want, wrap it, send the token to the other party, and the other party logging into Vault and then unwrap it, and they get the secret.
Okay, great. Thank you for that. The next one is also from Jesse. The question is, does HashiCorp have a published HECVAT? So at this time, Jesse, we do not. It's something that is in the works, and we are working on it now. Any additional input or framing around that would certainly be helpful, but it's not currently published, but it is in the works. And Nick Popovich is also on the call with us. He's my colleague here at HashiCorp. He can provide additional information as we move forward on that. Okay, next question. This is from an anonymous attendee, so thank you for being here. What about application deployment or configuration, not just VMs, for Windows apps? So this is an interesting one. So I'll jump in on this one a little bit, and then Mehdi or Grant, if you want to add a little bit more about what you're doing around that, that'd probably be helpful, as you have real world application of what you're doing here. So from a broader perspective about application deployment and configuration for VMs or pretty much any application or infrastructure, of course, HashiCorp has tooling that can help automate those types of deployments. So whatever additional capabilities are required or infrastructure you need, whether it's a VM or you want to send up a container or networking or storage or anything around that, Obviously, you heard Grant talking about Terraform earlier. Terraform is the infrastructure as code solution from HashiCorp. You can use that to deploy any type of infrastructure, right? So the necessary VMs, you want to host Windows in it or Linux in it, you want to stand up a Kubernetes cluster, or any of those kind of things, you can use Terraform to automate and do that. And as you already saw earlier with the University of Florida workflows that Grant went over, you can use the automation capability to pull the secrets from Vault as you're building out these applications in these environments. So then once you stand them all up, as far as configuration and adding updates or patches, whatever, to your environment, a couple of things around that. You also heard Grant talking about some of the configuration management tools. HashiCorp is very complementary for a lot of those tooling that's out there. You probably heard of Ansible and Chef and those things. So it's a better together type of solution. But we also see different customers who take an immutable approach, right? Where they stand up an environment and then they have that in production. And as they roll out a new environment or new patches or new updates, they don't keep the old environments around, right? They just publish a new environment because everything's automated. So it's very immutable, right? There's no long-term type of operational infrastructure. I just publish a new one and deploy that. And then once everything transitions over, I'll tear down the old one. So those types of approach. So I don't know, Mehdi or Grant, you want to add a little bit more about what you're doing around this environment for deployment and configuration for Windows applications?
Yeah, there is one use case, for example, Chocolatey. We do a lot of deployments using Chocolatey and through Ansible. Like Tim said, the same concept applies. For instance, if you have a software, we have one application that needs a username and password to be able to onboard that VM to a very specific tenant. Those secrets, they just get pulled from Vault, the same way that Terraform will pull the secrets for, your vSphere environment or your AWS. The teams use it. I haven't heard any, issues or like difficulty using it, as long as you have the appropriate role and it has the appropriate policy that grants it access to the specific path, you're good to go. And regardless of whether it's Linux or Windows.
All right, thank you. Any other questions out there, Brittany or Harrison, that's come up? I don't see any in the Q&A section, so we covered on those.
Sure, but I do have a few questions for our speakers since we do have the some more time left. So if you don't mind, how can Vault generate and manage certificates and act as a certificate authority so you won't have to use external CA?
Thank you, Brittany. I can jump in that a little bit, and then if Grant or Mehdi want to chime in as well, because that's something that they're looking at. So you're already heard through what the University of Florida is doing, some of their workflow. They are using Vault to store and manage some of the certs, but Vault can also act as its own certificate authority. And we have a lot of customers that actually do this today. It can be a root or an intermediary CA and generate the necessary certs and manage them for you all the way through the process. Right? So Vault can actually act as a CA on your behalf and issue those certs and manage them. And the other interesting aspect of that, just to add on and to increase your security posture, which again, we see this being used a lot today, is the concept of a dynamic secret. And Vault supports this dynamic secret capability that says, I'm going to generate a secret, right? Some kind of a confidential information, say a cert in this case we're talking about. I'm only going to give it a short time to live. And it could be a minute, an hour, a day, a week. And I just publish the cert, use that, and then it expires, right? Because it's dynamic and it's no longer out there. It's no longer exposed. Even if somebody got their hands on it, you can't use it because it's expired. And this applies to a lot of the secrets environments within Vault, is I can give this short time to live or this dynamic capability that generates a credential or a secret or whatever I want to use for a very short period. I use it, I do the work that I want to do, and then it's gone. And much more secure. I don't have to worry about, this sprawl effort of something get exposed in the long term and those kind of things. So, and I know you're looking at some of the PKI engines, Grant and Mehdi, I don't know if you want to add on to that a little bit.
Yeah, I'll let Grant elaborate on that more.
Yeah, so I mean, one of the ones that I mentioned before is what we're doing for SSH authentication. That's our primary use case, I would actually say. as far as like SSL certificates related to, like web servers and stuff, we had conversations about leveraging Vault as a CA, but ended up kind of moving away from that idea just so that we didn't have to deal with making sure chains were in order, essentially. But for other use cases, we were actually looking at it for a infrastructure as far as mobile authentication as kind of a way to handle those short-term time to live things. But we've actually moved in a different direction. Yeah, Med, can you think of any other ones that we've really been looking at?
No, those are the ones we've looked at. Yep.
Okay, thank you. I saw another a question popped up here. It says, is there a notification feature about a type of event change in HashiCorp? I'm assuming we're talking about Vault here, such as a secrets update to recipients or users. So I'm not sure if I fully understand the question, but I'm assuming some kind of notification that says a secret has been rotated or updated, or maybe there's an approval that's required before a secret is granted to somebody. So there are those types of notifications that are there. Vault will log and track everything that happens within Vault. So every transaction that happens, everything that's there is automatically tracked by Vault. It's logged, and you can use that to into an aggregation system of some sort, Splunk or other, to grab all that. There's also an ability to provide an authentication mechanism beyond the normal auth engine that says, I want I as a requester want to use this specific type of secret, and maybe that request has to go to Medi, for example, for approval before I get access to that secret. So those kind of things are within Vault. As far as just a general notification system, hey, your password's about to expire or something like that. Those types of things, Vault usually is programmed to handle automatically. It generally is not a general notification flag that's set. Some additional code or programming would have to be provided to pick that up from Vault and pass it on to a user.
Thank you, Tim. I do have a question. Is Vault FIPS, I'm gonna go with that, 140-2 compliant?
Yeah, so I can take that one. Very, very common question. Thank you for that. So today, as we already talked about earlier, Vault encrypts everything, right? So all the secrets, everything in Vault is encrypted. Where FIPS 140 is required, Vault does support FIPS 140 compliance. So that's a Vault Enterprise capability. It's not included in the Community Edition, but it is FIPS 140 compliant. There's several different ways we can do that within Vault, depending on your architecture, how you want to support it, what FIPS level you require, and all those kind of things. So there's multiple ways to do it, but fundamentally the answer is yes. If you need FIPS 140-2 compliance, we can provide that using Vault Enterprise.
Awesome. Thank you so much. Thank you again to Tim, Tara, Medi, Grant for your presentation. I'd also like to thank all of you for joining us today. We hope that you found this webinar was informative and helpful to you and your organization.